This video is going to cover the screw problem that you were assigned. So the first thing we need to do is do our sketch, and the problem says that you have a 7/16 inch nut driver with a 1.5 inch diameter. So let's draw what that might look like. Here we know that the diameter is going to be 1.5 inches. It also gives us the diameter of the axle, which isn't going to be relevant to solving this problem, but that would essentially be this here. Okay, the other information it gives us thread information for the bolt itself. So if we drew the bolt, and these are the threads, the first number is going to give us the diameter of the bolt itself, which is from here to here. The second number is going to be the TPI. So each one of these lines here represents a thread, and the distance between each thread is what we're going to call a pitch. And if you remember, the equation that we defined for pitch was equal to 1 over TPI. Okay, so we're going to use that equation later. And then the UNC is just a description for the bolt, whether it's coarse or fine, which isn't applicable to solving this problem. Okay, so we've done our sketches. So here's a sketch of the nut driver, and here's a sketch of the bolt. The first thing it wants us to do is determine the circumference where the effort force is going to be applied. So the effort force is actually going to be applied in a clockwise direction when we're turning the handle of the nut driver itself. So that's going to be what we call our FE. The resistance force is going to be perpendicular to that, actually facing downward. So the circumference is actually going to be a circle. So if we look at the distance that effort force is traveling, it's going to be the circumference of a circle. And we know the diameter of that, and the equation for a circumference is 2 pi r, or you can do pi d. So the answer would be 1.5 times pi. Determine the pitch of the screw. We know the TPI, so 1 over TPI, and that would be 1 over 20. Remember, it gave it to us in the thread information, and that's where the 1 over 20 comes from. So that's the pitch, based off this equation here. What is the mechanical advantage gained in the system? Another one of our formulas is IMA is equal to the circumference of the effort force divided by the pitch. And we've already determined our circumference, and we've already calculated our pitch, so we just need to plug those numbers in. Pi divided by 1 over 20. So if you do the math, you come out with 94.2 for your IMA. Okay, the last problem states that how much force can be overcome when 5 pounds of force is exerted. So here we know that our FE is going to be 5 pounds, and it wants to know what our FR is. Okay, if you remember earlier, I said that your pitch is also going to be your DR. So your pitch is going to be your DR. So then our DR would be 1 over 20. And then our DE is going to be the distance that the effort force is traveling. So back to this, the circumference of the circle here, the distance my effort force is traveling is a circle, right? So the DE is going to be the circumference of that circle, which we've already calculated to be 1.5 pi. So we can use our equilibrium equation to solve for our unknown, which is going to be the FR. So we plug in our values for that, we get 5 times 1.5 pi divided by 1 over 20. And that gives you 471 pounds. So that's your FR. So you could see that you're applying 5 pounds of force, but you're getting 471 pounds. So that is a huge mechanical advantage. And that's one of the great things about the screw as a simple machine, is that the mechanical advantage compared to the other simple machines is greatly magnified. All right, that's all.